For today's class, we are going to look into change of subject of relation, and some people call it change of subject of formula. For example, make x the subject of ax equals b, meaning we want x to stand alone. So the equation is ax equals to b. Since we want x to stand alone, a and x are connected by what? Multiplication. So to remove this a, we have to divide both sides by the coefficient of x, which is a over a over a. And what happens there? A cancels a, so what's x becomes b over a. Finish. X is now the subject of the relation. So let's make it a bit difficult. We still want to make this x the subject. So this c, we don't need it. So we need to take this to the other side. And when this plus c crosses, it becomes minus c. So we're having ax equals to b minus c. To get value of x, we need to divide through by what? A. We don't need this a to be here. So that goes by a. So from here, a cancels a. Hence, x becomes b minus c over a. Let's make it more difficult. Our aim is to make x the subject. Now there's a problem. We have x here, we have x here. So what are you going to do? We are going to collect like terms. Those with x, let's bring them to the left hand side. Those without x to the right hand side. So here we have ax. Now this b also has x, so I'll move it. There's a sign beside it here which is plus. When this one crosses, it becomes minus b x equals to this stays. But this c has no x, so we'll take to the other side. So plus c turns to minus c. What now left? X is common, so we factorize x. So we let it a minus b equals to d minus c. Since our aim is to get x, this a minus b should go. So we divide both sides by what? A minus b over a minus b. So this cancels. So from here, x equals to d minus c over a minus b. Let's make it more difficult. Don't be scared. It's not difficult at all. I'm just saying make it more difficult. So anytime you see brackets, we like to expand. So what are you to do here? If you expand here, b is b multiply a. B times a is ab. Then with x. B times b we have bd. Then we have x standing here. We can try to expand this first, or we can still leave it. But I will not. Let's just expand. Let's expand. Although we don't need to expand here because x is common. But let's expand. Or we should not expand. But let's expand. So x times d will give us dx. Then we have minus b times x bx. Then plus cx. So what next? If you notice, we have x here, we have x here, x. Do you know without x is bd? So we can try to move bd to the other side and this one to this side. So here I'll be having abx. This x stays plus x. This dx will cross and becomes minus dx. This plus bx cross and become plus bx. This plus cs cross and become minus cx equals to. So this leaves, this stays, these two. Wait, so this and this is here, this is here. This d moves, bx moves, cs moves. But this bd doesn't have x. So we take to the other side and becomes, that's plus here, becomes minus bd. So what happens here? X is common all through. So if we factorize x, here we left ab. Now x has a coefficient of 1 here, that's plus 1. Then minus d plus b minus c equals to minus bd. Do not panic. Mathematics is simple. We can just make it look difficult. So everything here we don't need it. So we divide through by everything we have here. Divide both sides by what we have there. So we have ab plus 1 minus d plus b minus c. So what happens here? We do the same thing here. ab plus 1 minus d plus b minus c. So the whole of this cancels. So our x becomes minus bd. Everything divided by what do you have there at the denominator. And that is our final answer. So all this one, they do not involve any fraction. So let's take questions that involve fraction. Our aim here is still to make x the subject. So what can we do here? Note, anytime we have fraction, we can write this question as ax over b equals to c over 1. So if you have a fraction, another fraction here to each side, we can just cross multiply. 1 multiply ax remains ax. B multiply c gives bc. Since our aim is to get x, we divide through by what? A. Divide both sides by what? A. So from here, a cancels a. So it implies that x equals to bc over a. Let's take another example. In our next question, we try to throw x away. Okay, this time around, We want to make A the subject. And when you notice, this is only where A appears. This doesn't have A, this doesn't have A. So those without A, we can take them to the left hand side. So this becomes S. This U has plus here. When it crosses, it becomes minus UT. And this remains half 80 squared, or 80 squared all over 2. Why? Half of any number is sitting as that number divided by 2. So half of 10 is 10 divided by 2, 5. So half of 80 squared is 80 squared divided by 2. And what do we have here? We have 1 here. So by the time we cross multiply, 80 squared multiply 1 is 80 squared. Then these 2 multiplies everything you have here. 2 into S minus UT. To get A, this T squared must go. So we divide both sides by what? T squared. So that A can stand alone. So this T squares cancel T squared. From here, it implies that our A becomes 2 into S minus UT divided by square of T. For the next question, we want to make V the subject. So what do you notice? I can still write as S equals to U plus V over 2. Then I can put over 1 here. It doesn't change anything. Now, if we cross multiply, 1 multiply the whole of this, it remains as U plus V T. 2 multiply S becomes 2S. So V you want to get is in brackets, so we expand. T times U, UT. V times T, VT equals to 2S. So since our aim is to get V, this UT has to go to the other side. There's invisible plus here. So here our VT becomes 2S. This cross term becomes minus UT. Since our aim is to get V, we need to cut the T away. So divide both sides by T. Then from here, V becomes 2S minus UT over T. Just like this. Now let's take an example that involves square. Here our aim is to make U the subject. So what happens? This doesn't have U, so we can take this to the other side. So we have V squared. This plus cross term becomes minus 2 years. Then U squared remains here. Now, for us to get the value of U, we need to take that square away. Note this. To take square away, we look for square roots of it. So square roots comes to square. But anything you do here, you have to repeat the same thing at the other side. So this square root take this square away, so we left it to U alone. And that U alone remains square root of V squared minus 2AS. But note, this square root cannot cancel this because of this minus. So we leave our answer this way. Let's take another example. Here our aim is to make V the subject. So this can be written as F over 1 equals to mv squared over r. If you cross multiply, mv squared multiplied by 1 is still mv squared equals to fr. Then from here, our aim is to get V. So this m has to go. So we'll divide both sides by m, divided by m, divided by m. This takes this away. From here, V squared becomes fr over m. For us to be able to get the value of V, we have to what? Square root this, square root this. This, then V becomes square root of fr over m. That is the answer to that. Let's take a question that involves square root. For this particular one, our aim is to make L the subject. Solution. We have T equals to 2 pi root L over G. So what I'll do here, since L is within its square root, nothing should be beside the square root. So we can divide both sides by 2 pi. So I'll divide this by 2 pi, this by 2 pi. At the end of the day, this 2 pi cancels this 2 pi. So I'll be left with T divided by 2 pi equals to root L over G. We can't get this L until we remove the square root. Note, to remove square, we square root. And to remove square roots, we square. This time around, we have square roots, so we square. So if we square this side, we have to square the other side too. So from here, we have 2t over 2 pi all squared equals to, or have here L over G, because this square, take the square root away. Now our aim is to get the value of L. So I want to do something simple here. I can divide both sides by 1. I can divide this by 1. It's not still changing. Why? I want to cross multiply. L times 1 is L. Then G multiply the whole of this. So I'll be having G into bracket T squared over 2 pi, t over 2 pi all squared. Or another person can decide that, oh, from here you might not see this, so you can decide to expand this. T raised to power 2, we have t squared. 2 raised to power 2, we have 4. Then you have pi raised to power 2 equals to L over G. Then you can cross multiply. From here, this multiply this, so we have 4 pi square L equals to G t squared. To be able to get value of L, we have to divide both by 4 pi square so that L can stand alone. So from here, 4 pi square cancels 4 pi square. Then L becomes gt squared over 4 pi squared. So these ones are the same, just that here we factorize all the perfect squares. So these answers are the same. Now for this particular question, our aim is to make V the subject. Now here we have 3 fractions. The examples we've done previously, we have only 2 fractions. Whenever we have 3 fractions, recall, we need to get rid of all the fractions in one step. So what are we going to do is to find the LCM of all the denominator. So we have FUV, so the LCM is FUV. So multiply each fraction with the LCM, which is FUV. So multiply the left hand side and right hand side by FUV. So if this FUV multiplies this F, what happens? This F will cancel this F, so we let UV. UV multiplied by 1 will give us UV. So here we are going to have UV. Then we have equality sign here. Now, this FUV multiplies 1 over U. U cancels U, we have FV left. Multiplied by 1, we have FV. Plus V cancels V, we have FU. Multiplied by 1, we have what? FU. Now, our aim is to get V. So we have V here, we have V here. So bring this one here. So we are having UV minus FV equals to FU. Then we factorize the V. So we are having U minus F equals to FU. So for us, our aim is to get V. So we divide through by U minus F in order for us to be able to get the value of V. So from here, V equals to FU over U minus F. Let's increase the difficulty level. Actually, there's nothing difficult here. So, solution. Given that M is V over U and 1 over F equals to 1 over V plus 1 over U, the question says express M in terms of V and F. Meaning we want M to be in terms of V and F. Meaning we don't want to see U. So since we don't want to see U, what are we going to do? It's either we make U the subject here, then we put it here, or we make U the subject here, then we put it here. And it's easier for us to make U the subject here. So from here, if you make U the subject, U becomes V over M. Note this shortcut in mathematics, it is allowed. When we have something like this, we can swap. You can bring this U here, this M here, very quick. So we are going to avoid 2 steps, cross multiplication, divided both by M. So that's U. So we now come back here. So it implies that from here, 1 over F equals to 1 over V plus 1 over U. If U is V over M, note that again. If U is V over M, 1 over U, the reciprocal becomes what? M over V. You can just swap it. So if U is V over M, 1 over U is what? M over V. So let's write 1 over U here, put what? M over V. Then from here, we can just say, we can factorize this V out. So we can say 1 over F equals to, if you remove 1 over V, I'll let it what? 1 plus M. Yes. Because I take this V away, nothing here. I take this 1 over V away, nothing left here. So since our aim is to get M itself, we can just, oh, don't worry, let's just use the same method. I don't want to confuse you. Let's use similar example we used in our previous example. What's the LCM of FV? V and V are equal, so F and V, the LCM is just FV. So let's multiply by FV. So F will cancel F, we have V left, multiplying 1, we have V. Equals to, V cancel V, we have F, multiplying 1, we have F. Plus V cancel V, we have F, that's MV. What's our aim to get M? So we can make this V here. So V minus F equals to MF. Since our aim is to get M, we'll divide both sides by F over F. So this cancels this. So from here we can say M equals to, what do you have here? V minus F over F. So that is the connection between m in terms of v and f, no u. Then next, hence also express m in terms of u and f. This time around, initially we eliminated u, but now we are going to eliminate v because we want m to be in terms of u and f, no v. We'll come back here again. Since m equals to v over u, to get v directly we can just cross multiply this over 1. So from here it implies that v equals to mu. Then we'll go back to the second equation, 1 over f equals to 1 over v plus 1 over u. From here, this one, 1 over u. So we want to replace v with mu. So here it implies that we have 1 over f equals to 1 over, instead of v, write mu plus 1 over u. This is u. So same thing, we multiply through by the LCM. The LCM of mu and u is mu. Then the LCM of fmu is fmu. So multiply by fmu. So what happens here? F will cancel what? This f will cancel this f. So we have mu left. Multiplying 1, so we have what? Mu equals to mu cancel mu, we have f left times 1 f plus u cancel this u, we have fm times 1, we have fm. Our aim is to get m, so bring this fm here. So we have mu minus what? Fm equals to f. So factorize m, so we have u minus f equals to f. So from here, to get the value of m, we'll divide both sides by u minus f. U minus f. So at the end of the day, the value of m becomes f over what? U minus f. That's it. So initially, m is what? V over u. We are done. I'm just trying to bring something together. And from here, m is also v minus f over f. And from the last one, m is also f over u minus f. This particular formula is very useful in physics under optics. So formula for magnification, image distance, object distance. So this is quicker method using instead of using this formula. But in short, for you, for your own case, for the mathematics, this is where your business lies. Let's take another question. Here our aim is to get the value of r. So what can we do here? We can write this as a over 1 equals to pi r squared minus r squared all over 3. It is the same. So let's cross multiply 3 times a, we have 3a equals to 1 times this, nothing changes. So let's just expand this. Pi times r squared, we have pi big R squared minus pi small r squared. Since our aim is to get this small r squared, I would like to move this one here. Why? Because the negative sign will turn to positive. So this minus pi r squared, when we bring it here, becomes what? Plus pi r squared. Then this one remains pi big R squared minus 3a. Our aim is to get a small r. So what can we do here? We can divide both sides by pi. Because our aim is to get the value of r. This cancel this. From here, r squared becomes pi big R squared minus 3a over small pi. In order to get the value of r, we need to take the square away. And how do we take square away? We find the square root. Anything to this side, do to the other side. From here, the square root cancels the square, so r becomes the square root of pi big R squared minus 3a over pi. That's the answer. Note, this pi cannot cancel this pi because of this minus. So the only thing you can do is to split. Especially in objective question, you might not see this. So we split, we having pi big R squared over pi minus 3a over pi. Pi cancels pi. So this answer can still be expressed as the square root of r squared minus 3a over pi. So this and this are still the same thing. For this particular question, our aim is to get a. And I told you, if you have something like this square root, ensure nothing is here. I can write this question as f over 1 equals to pi t minus a over mu divided by 2l. Note, if I have 1 over 2x, it's same thing as what? X over 2. If I have 1 over 2l times p, it's same thing as p over 2l. So this same thing. Why? So that we can easily cross multiply. So if 2l multiply f, we have what? 2lf equals to square root of t minus a over mu. What next? since we want to get a, the square root must go away. How do we remove square root? We square. We square both sides. We might not need to expand this. Leave it as 2lf all squared. And here the square, take the square root away. So I'll be having t minus a over mu. I can put over 1 here. So by the time we cross multiply, this multiplies this. So I'll be having mu outside. Then multiplying 2lf all squared equals to t minus a. Our aim is to get a. So this negative a, I can bring it here. It becomes what? Positive a. This still remains. This has plus here. When I bring it here, it becomes minus mu 2lf all squared. And that is the final answer. Okay, let's take two of our questions. Alright, look at these two questions. Don't be scared, don't be scared. They are jam questions, but it doesn't matter. One of the oldest jam question. So, similarly, I can just write it as over 1. So, 1 multiplied 2 over x, we have 2 over x. Then m multiplies everything we have here. So, I'll just write m multiplies 1 over p squared plus 1 over q squared. So let's try to write this one as a simple fraction. So this is 2 over x. Let's leave the m outside. For this, the LCM is what? P squared, q squared. P squared cancel p squared, we have q squared times 1, q squared. Then q squared cancel q squared, we have p squared left times 1, p squared. So this m, we can attach the m to the numerator. Still the same thing. What next? Since our aim is to get x, we can cross multiply. So this will multiply x. So I'll be having xm into q squared plus p squared equals to 2 multiply p squared q squared. Since our aim is to get x, we divide both sides by this to make x stand alone. Q squared plus p squared over m into q squared plus p squared. So from here, this takes out this. So we have x left. X equals to 2p squared q squared over m into bracket. I can write p squared first. P squared plus q squared. And that is the answer. As simple as that. Now coming to this, it looks difficult, but shh, don't panic. First, we want to make t the subject. No t here at all. So we don't have much issue here. Now this t here. To get this t, we have to take this away. What is this? This is cube root. Now, if I have square roots of a, to remove the square root, I'll square so that we have a. If I have cube roots of a, to get a, I'll cube the both sides to have a. Now, what happens here? I first have to remove this cube root. And to remove cube root, we have to what? Cube both sides. So we have ab over 1 minus b all cube equals to cube root of 2v plus t over a plus 2t all cube. So we can decide to leave this one as a single fraction. I think that's the best so that it will not complicate your work. So I can write this as av over 1 minus v all cube equals to this cube, take this cube root away. So I'll be having 2v plus t over what? A plus what? 2t. Now here, it's either we split or we leave it this way. Okay, let's leave it this way first. To leave it this way, I can write this everything as over 1. So we can multiply. So 2v times 1, we have 2v. 2v times 1 is 2v. Then t times 1, we have t. Then a multiplies the whole of this, so this equals to a into av over 1 minus v cubed. Then 2t can also multiply it to be having 2t multiplying the whole of that. That's what? av over 1 minus v all cube. Note, our aim is t. So we have t here, we have t here. So let's leave this t here. This t remains. Now this one will bring everything here. So that will be minus 2t into what we have av 1 minus v all cube. This has no t, so it remains as a into av 1 minus v cube. Then this 2v, we bring it here, it becomes minus 2v. So we can factorize t here. Note there's a invisible one here. So if I factorize t, we are going to be left with 1 minus 2 into av 1 minus v all cube equals to a into av 1 minus v all cube minus 2v. Now if you notice this t, So the whole of this doesn't have t, this doesn't have t. So I can divide both sides by this coefficient of t, which is what? 1 minus 2 into AV, 1 minus V cubed. Same thing goes here. 1 minus 2 into AV, 1 minus V cubed. This goes, so our t becomes A into AV, 1 minus V cubed, minus 2V, divided by 1 minus 2 into AV, 1 minus V cubed. Is our final answer. As you can see, there is no t here. Looks clearly right, but to me it looks beautiful. But there's something about mathematics. If it's OBJ, you might not see this in your final answer. So, but you can always manipulate this to fit any of the option. Or from here, we have AV. I will not put 1 over here. I can take this as a fraction itself. So I will expand this cube for both numerator and denominator. So this becomes AV all cube 1 minus V all cube equals to what do you have there? 2V plus t over what? A plus 2t. Then we cannot cross multiply. So let's see what this one will lead us to. So A multiplies the whole of this. So I'll be having A into what? AV cube then 2t also multiplies it, so we'll be having 2t AV cube equals to this 2v multiply this, we're having 2v into 1 minus v cube, then t multiply it, you're having plus t 1 minus v cube. So we have t here, we have t here. So this one remains here. So we're having 2t AV all cube. Then this one will bring it inside, that will be minus t 1 minus v all cube equals to this side, this one remains 2v into 1 minus v all cube. Then this one goes, we have plus here, it crosses and becomes minus a into AV all cube. So t is common. So if we factorize t here, we let it 2 into what? AV all cube minus what? 1 minus what? V all cube. Then here, everything we can write as 2v 1 minus v all cube minus a into AV all cube. So what next? We can just divide both sides by this. 2 AV all cube minus 1 minus v all cube. 2 AV all cube minus 1 minus v all cube. So this goes. So t becomes 2v 1 minus v cube minus a AV cube divided by 2 AV cube minus 1 minus v all cube. So what we have here and this are the same, but they look different. But this one is more simplified than this, because here at the numerator we still have a fraction. We still have a fraction at the denominator, but here no fraction at the numerator, no fraction at the denominator. So if I'm to advise, I think you should stick to this one. But sometimes this one is safer or faster. Look at the board. It looks beautiful, right? To number lovers. Let us take 2 more. For this particular question, our aim is to make f the subject. Luckily, nothing is here, so we can just square both sides straight. If you square both sides, we're having t squared equals to, if you square square root, what happens? The square root goes away. So we're having v over 1 over f plus 1 over g. We can take this as a single number, then this one over 1. So what happens here? We can just cross multiply. Oh, look at this. Because if you cross multiply, this might look more confusing. Look at this. In maths, this side can divide this. So I can say the whole of this over 1 over f plus 1 over g, everything divided by 1. This over this equals to this over this, v over t squared. It is allowed. So if a over b equals c over d, we can say d over b, d over b equals c over a. Is allowed in mathematics. Or you can say a over c equals to b over d, a over c equals to b over d. Because if you cross multiply, you see have ADBC, so it's allowed. So and I know if I divide everything by 1, it remains the same thing. So I can just write this one as 1 over f plus 1 over g. What's our aim? To get f right. So you can either multiply 2 by the LCM or, yeah, I think that's faster. Let's just multiply by the LCM. What's the LCM? FGT squared. That's FGT gt squared. So what happens here? F cancel F, so we have gt squared multiplied by 1, that's gt squared. Plus g cancel g, we have ft squared times 1, that's ft squared. Equals to t squared cancel t squared, we have fg times v, that's fgv. Since our aim is to get f, I'll bring this f to this side. Why? Because I want this one to stay positive. So this is gt squared equals to fgv minus ft squared. Then from here, we can factorize f from the right hand side. And from here, we can write gt squared equals to factorize f gv minus t squared. Since our aim is to get value of f, we'll divide both sides by this. gv minus t squared, gv minus t squared. This cancels this. From here, f becomes gt squared divided by what? gv minus t squared. As simple as that. Last question. Is this familiar? Not to feel student, but is it familiar? Yes, it's one of the first 5 questions we solved. But earlier on, we are told to make A the subject, but this time around, we are told to make T the subject. And this is very much difficult. Why? Whenever you have an equation that is expressed linearly, no brackets, no square roots. So, if what we are looking for appears and its square also appears, this is a quadratic what? Expression. Or let's say equation, this is what equals to. So for example, let's suppose I have 2x squared plus 5x plus 7 equals to 0. Or equals to minus 7. We're not to make x the subject of the formula. All the method we use, if you try the approach, you will not get it. You're not going to get it, but it's quadratic. So similar to this, you might not actually see it, but it's quadratic. So this particular question was given to a particular teacher during an interview, and the teacher spent over 30 minutes, and at the end of the day, the question remained unsolved. Why? Because the teacher refused, or the teacher failed to realize that this is quadratic. So when you have a letter and square appear in the same equation, it leads to quadratic. Now, what I'm going to do here, let's write it as a general form of quadratic. Let's move this R first, multiply 2 by 2. So if we multiply 2 by 2, what happens? There won't be fraction again. So you have 2s equals to 2ut plus 80 squared. What next? We write the square first. We write 80 squared first plus 2ut. Then bring this 2s inside, becomes minus 2s. Nothing left outside equals to 0. So now look at this. This is equation of t. General form of quadratic equation is what? As squared plus bx plus c equals to 0. And for every quadratic equation of this form, x equals to minus b plus or minus square root of b squared minus 4ac over 2a. This will be faster, although we can also use completing the square method. So in this case, what's our x? Our x is t. So t becomes minus, what is b? B is what is beside t, and that's 2u. Plus or minus square root of, what is b? 2u. 2u squared minus 4. What is a? A is a. C is minus 2s. Minus 2s. Over 2a. Our a is a. So t becomes minus 2u plus or minus square root of 2 squared is what? 4u squared. Minus minus give us plus. Then we have what? 4. Then as. 4as. Yes, over 2a. We are not done because 4 is still common inside the bracket. Sorry, the square root. Plus or minus, we carry it as root 4 into bracket u squared plus as. Divided by what? 2a. So our t equals to minus 2u plus or minus square root of 4 is 2. That's 2 roots u squared plus as. Oh, there is a mistake. 4 times 2 is 8. So this is 8. After factorizing 4 out, 2 will still be left here. That's 2as over 2a. At the numerator, 2 is common. So we bring out 2, that is minus u plus or minus square root of u squared plus 2as over what? 2a. These two cannot cancel these two. Hence our t equals to minus u plus or minus square root of u squared plus 2as over a. And this is our final answer. Finish. Finish, students. Equation of motion. So we are done with this subject. We are done with this topic rather. So let me just manipulate this. I want to get something out of this. Look at this. When you go back, we are done. So this just physics now. Because this some of this equation at least you come across. in physics. If you recall, one of the equation of motion is v squared equals to u squared plus 2as. If you are not a physics student, you can just end the video and go and play. But by a physics student, let's see something beautiful come out from here. So this is one of the equation of motion. So from here, I can replace this u squared plus 2s as what? As v squared. So this becomes t equals to minus u plus or minus square root of everything here becomes what? V squared over what? A. So t equals to minus u plus or minus square root of v is what? Square root of v squared is v over what? A. So let's multiply. From here it means 80 equals to minus u plus or minus v. So from here plus minus v becomes what? U plus 80. So we take the positive value of v equals to u plus 80. Is it familiar? Yes, equation of motion. But don't worry about this. See you in my next class.